In this video, we will discuss another two-dimensional motion which is known as circular motion. So first of all, what is circular motion? If a particle or an object moves centering a point and an axis in a circular orbit, then that motion is called circular motion. So there is 2 points. One point is centering a point and an axis. This axis and a point is this is an important point, and it rotates in a circular orbit. So the movement of the motion is a circular uh, path. So let us take an example. A stone swinging in a horizontal circle at the end of a string. So suppose this is our string and this is the stone, and at that end I hold this end of I hold this end of this string with my hand. So when I swing the stone will be move around like that. If I swing that at horizontal axis. So here this point, or the point I am holding this end of the string, it is the centering point, and my hand is acting as the axis. My hand is acting as the axis, and the path of this stone, when I swing this stone, the path of this stone will be a circular orbit. So this is a circular orbit. Circular orbit. So I can say that this motion is a circular motion, and there are two-dimensional in that case. One is the axis, the y-axis, and I rotate this stone at the horizontal axis, that is x-axis. So I can find two axes. So this is a two-dimensional motion. Similarly, we can take an example of electric fan, and we can take an example of moon circling the earth. All of the examples is the example of circular motion, or we can say that two-dimensional circular motion. Here another point is, this portion is a radius, as we know about the theory of circle, but this radius is known as radius vector. Radius vector. So when I use this sign, then you will think that this R I represent as radius vector. Now coming to the next part, in our linear motion chapter, or in previous projectile motions, we discussed some terms like displacement, velocity. In circular motion, there are some terms like displacement and velocity. In circular motion, this displacement is known as angular displacement. Angular displacement. So what is angular displacement? An object or a particle, when moves round a point as center, the angular distance it travels is called angular displacement of that object or particle. Suppose this is our circular path, and a body moves from A point to this B point. So this is the path of the body, and when it goes from A point to B point, it makes an angle of theta with the center. This theta is known as angular displacement. This theta is known as angular displacement. Here is a formula for angular displacement, which is, if the displacement is theta, we can write this theta, which theta equals to arc by radius. arc by radius. Suppose here the arc is AB. The arc is AB and the distance of this arc is suppose S. So we represent this, the distance from A to B is S, and suppose the radius of this circle is R. So from that we can write theta equals to S by R, or we can write S equals to R theta. And here is an important point, theta is in radian angle. Theta is a radian unit. So we will not consider this theta as a degree. Instead of degree, we will consider this theta as a radian. Okay. Then coming to the next point, which is angular velocity. Angular velocity. So what is angular velocity? The angular displacement of a rotating body about a center or axis divided by the time taken for that displacement is called average angular velocity. So when it goes from point A to point B, suppose it takes t time. It takes t time. So uh, by the definition of angular velocity, we can write, we represent angular velocity as omega. We can write omega equals to theta to del of theta divided by del of t. From A point to B point, when it goes from A point to B point, it takes t time, and the displacement of this point A to point B is suppose del of theta. So we can write angular velocity equals to omega by del theta by del t, or we can write this as del theta by t. Del theta by t. So this is our definition. By the definition of angular velocity, we can write this thing as that manner. Here is another term which is instantaneous velocity. Here instantaneous velocity is if the time interval tends to 0, the limiting value of the average angular velocity is called instantaneous angular velocity or angular velocity. That means that del theta will be del t will be tends to 0. It means the value of del t will be like 0.002 second or like 0.001 second, like this. So when the time is tends to 0, then that velocity will be known as instantaneous angular velocity. Instantaneous angular velocity. Here is a relation between angular velocity and time period. Suppose the particle moving from A point and comes from A point, and this is known as and when it goes from point A and comes against in point A, then this is known as time period. Okay, let me clear this thing to understand you better. If this is the body, if the particle moving from this A point and then again comes this A point, and the time taken for this whole path is capital T, then this T is known as time period. Or we can say that the particle is moving the circumference of the circular path. So by the definition of this angular velocity, we can write for omega, we can write as the del theta equals to our circumference, because it moves along the circumference, and we know the circumference is 2 pi, and the time taken for the for go for point A and coming again to point A is t, which is time period. So we can write the omega equals to 2 pi by t. It is known as relation between angular velocity and time period. So this is known as relation between angular velocity and time period. Now coming to the next part, which is the direction of angular velocity. Here we can see, and this is an figure. This figure shows us how we can find out the direction of angular velocity, and from that we can write out angular velocity is a vector quantity. So to determine the direction of angular velocity, we will use right hand rule. Right hand rule. So what is in that right hand rule? If the motion is in the motion of the circular path is in is anti-clockwise direction, not clockwise. It is anti-clockwise direction. Anti-clockwise direction, then the direction of the angular velocity will be in upwards. And when it is in clockwise direction, then the direction of the angular velocity will be in downwards direction. And we find out this direction by the help of right hand rule. Coming to the next point, which is the relation between angular velocity and linear velocity. We know for angular velocity, we represent angular velocity as omega and we represent linear velocity as v. The relation between angular velocity and linear velocity is v equals to r omega, where r is the radius vector. And if we know r is a vector quantity, omega is a vector quantity, and v is also a vector quantity. So if I represent these three vector quantity, I can write the vector representation of this relation between angular velocity and linear velocity is vector v equals to omega cross r. So the relation is in the cross multiplication of this vector, or we can say that cross vector. So this is the relation between linear velocity and angular velocity. So that's all for today's video. In our next lecture, we'll discuss some more concepts of circular motion, also solve some problems problems about circular motion. Like this video and do subscribe to our channel. Thank you.